Okay, hello there. In this tutorial, we're going to go through some Quartus concepts that will help you with our week 2 lab. What we'll be doing in this particular lab that's related to the Quartus software is we'll be working with multiple schematics in the project environment. We'll see how to add and remove files from the project environment without actually deleting the files. We'll see why that's helpful when we have multiple files. We'll also then create block symbols from our schematics and show how to use them within a project environment. We'll discuss what Quartus means by top level entity and how to set it and change it. And then we'll also see how to use simulation names other than the default name of waveform. So for your lab exercise, you're given a circuit schematic, and in your pre-lab, you're working backwards to determine that schematic equation. What we're doing here is I'm going to give you an example circuit that we'll be working with. So our circuit output is named F. We have 3 input variables, A, B, and C. And so that circuit is a function of the sum of 0, 3, 4, and 5. So also in this lab, we're working with the concept of min terms and max terms. The sigma there, that Greek notation, whenever we say a circuit is the sum of, and we give these numbers afterwards, the numbers we've given are in base 10 decimal. That means we're going to, or the numbers in the sigma notation tell you where the ones are in your truth table. And you can see the truth table below. We've got our inputs, and then in the rightmost column, the output F. Right. And you'll see then that F is a 1 in row 0, where our binary inputs are 0, 0, 0. F is a 1 in row 3, corresponding to the 3. F is a 1 in row 4, and F is a 1 in row 5. And so the sigma notation tells you where the ones are in your outputs. And by default, then, anything not listed in here, you know, is a 0. For example, the zeros occur at 1, 2, 6, and 7. For this particular circuit, if we were to create a minimized sum of products form, which we haven't necessarily talked about how to derive that, but this would be the actual minimized equation. And so this is going to equate somewhat to the circuit that you were given and you've been working backward from. You have not been given a minimized sum of products, but you've been given a circuit and you're determining the equation. So we're going to use this as the given circuit schematic, similar to what we've been doing in the what you'll be doing in the lab. Also, then what we'll do is we'll go ahead and create a schematic for the canonical sum of products. So in your lab, you will be creating the same thing, a canonical sum of products and the canonical product of sums. And so here again, right, we have the same circuit equation, the same truth table. So the canonical sum of products form is a non-minimized form. It's where we then OR together. So the summation is the ORing. So this plus symbol is the logical ORing of the product terms, where the product terms are the min terms. So for min term 0, right, that's the min term created for row 0, where all of the inputs are 0, 0, 0. That min term is A naught, B naught, C naught. We're going to OR that with min term 3, which is A naught, B, and with C. We're going to OR that with the product term of min term 4, A and with B naught and with C naught, and we're going to OR that with min term 5, A and with B naught and with C. So that's our canonical sum of products form we'll be working with when we create that schematic. And then for the canonical product of sums form, well, this is the same circuit. Instead of writing the sigma notation here, I'm using the product notation, the capital Greek pi. And so whenever we use the product notation, whatever numbers follow that tell us where the zeros are in the truth table. You can see this is the same truth table. And we said that our zeros occurred at row 1, row 2, row 6, and row 7. And so canonical product of sums, that's where we solve for the zeros without minimizing. The sum terms are the max terms. And remember, max terms, we OR the inputs together so that they form a 0. And the product is that we're going to AND all of these summation terms, max terms together. So we've got, this is the max term, this is max term 1. So A ORed with B ORed with C naught, right? Max term 2, A ORed with B naught ORed with C, max term 6, and max term 7. So we'll be creating a schematic for this. So we'll be working with 3 different schematics for these different expressions for this circuit. And the overall goal of this lab is to show that even though we can derive different circuit equations, they are what we call logically equivalent equations, as they will produce the same output, this unique truth table output here. So we'll be showing that in the lab as well through simulation. All right, let's go ahead and we want to start Quartus, but with your lab, you are given a schematic. And so what you need to do is, I'm going to move this over. You need to create a folder for your Quartus project. Remember, we put all of the Quartus files within a folder that we create. If we don't, if you just put them in some directory, there's several files that are created and they'll be scattered throughout the directory. So we create a file folder for that. In this case, I've created this file folder named tutorial, right? Within that folder, when we open that up, I have a Quartus schematic, right? You'll want to do the same in your lab. I believe the schematic you're given is called circuit A. So you'll want to place that file within here, and then we'll see how to add it into the Quartus project. And so we need to create the Quartus project next, right? Close this down. I'm just going to start up Quartus. All right, just opening on my other screen. And so I'm going to use the new project wizard. If your view doesn't show up like this, as a reminder, you can say File, New Project Wizard, and get it from the menu. All right, we're going to say Next here at the screen. And first thing we need to do is tell this where we want to save the file. So where it says, what is the working directory for this project? Well, I'm going to go to that file folder that I have out on my desktop, that one named tutorial. That's the folder I want to select. So select folder. And then name of the project. Well, you know, for your lab 1, you might want to be naming it lab 1. Here, I'm going to call this tutorial, right? And whenever we name the project by default, it fills in the name of our top level entity as the same name. Now, if you know from the start that you want your top level entity to be a different name, you can always type that in here. But I'm just going to go ahead and click next. And I'm going to say use an empty project. And at this point, I could go ahead and add in the file in my directory. Actually, if I click here on these 3 dots and ask for it to browse, I have to go to my desktop tutorial, select that file, right? Say open, and that should add it into my project. I can say next. There's really nothing else I really need to set in this. I'm going to use the defaults for the device family. I don't need to change anything here. So I could be clicking on finish. I didn't. I got to the end screen. It gives me a summary of everything I've chosen. Right. I can always look at that and say, does that look good to me? If not, I can go back and make changes. But I'm just going to click on finish. And we're going to wait for it to open up our project environment. All right. So now, right in this project navigator tab, it shows here under hierarchy, top level entity. But if I click on hierarchy and say, give me the file view, you can see that we've got this PDF, which is a block diagram file in our project environment. So I'm just going to go ahead and double click on that to open it. And maybe zoom a little bit here. All right. So this corresponds then to the circuit you are given, right? Obviously, I'm using a different circuit. What I've done is I've used the text tool here to type in the circuit I'm working with. It's a good reminder for me to let me know where the 1s and 0s are when I test this. Right? I'll show you how to use the text tool when we create our own schematic. We've got our input pins here. We've got our signals named. I'll show you how to name these wires as well. But this actually then implements that equation. Actually, let me pop this back up here. Right, this is that minimize sum of products equation. B naught and with C naught, or with A and with B naught, or with A naught and with B. or and it was C. Right. And so by using some good signal names or corresponding signal names in here, right, I named the output of this NOT gate A naught, right? This is feeding A in, giving us A naught. This input pin B is feeding B in. The output of this NOT gate gives me B naught. C is the input here. I named then this wire C naught here. And then if I use these names as inputs to the AND gate, rather than directly drawing the wires, we can actually name the wires and it will make the connection. So it makes our schematics, when we've got a lot of wiring, it makes it easier to read because we don't have wires laying over the top of each other. We don't have to worry about actually getting an incorrect junction when we're drawing a lot of wires. So I prefer to name my wires. And so here I can see that, right, this is my B naught and with C naught. That'll be the output of this gate. The output of this gate will be A and with B naught. The output of this gate will be A naught and with B and with C. The results then of these AND gates are ORed together. So sum of products form, our lower level of gates is the AND gates, which flow into an OR gate. So here's our sum, here's our product of those sums being ORed together. And then the output pin I've named here, min SOP. I could have called it F, but I just wanted to call it min SOP to let myself know that this was my min SOP circuit. All right, so we've now successfully added this file to our project. If you didn't add it into the project as you were creating the project environment, so what I'm going to do is I am going to go over here, I'm going to right click and I'm going to say remove file from project. Am I sure I want to remove the file from the project? Yes. And what this will do is it will just remove it from the project environment. You can see it's no longer listed here, but if we go ahead, right, and look in our file folder, we have not deleted it. We simply removed it from the project environment. And you can see then as we created a Quartus project, it created then this QPF file, this Quartus project file here. It created that. It created this QSF, this Quartus symbol file. It created a subfolder DB with some database information that gets updated as we make changes to our program. Those are nothing that we have to maintain, right? Quartus project environment is creating them and maintaining them as we make changes in the environment. All right, so I just wanted to show you that even though we said remove, it didn't delete our file. All right, let's bring the Quartus project back up here on the screen. And so now if we wanted to go ahead and add this file into our project, we could go here to the project menu and we can say add current file to project. And this is the only file I have open right now. It's in focus. It will be the current file. So add current file to project, and you can see that shows up in our project environment again. All right, let's say that we wanted to simulate this. So we know we've, in the previous lab, right, we used a vector waveform simulation. We'll do the same thing here. We're going to say file, new. And that's under verification debugging. It's this university program VWF vector waveform. So I'll say okay. And it's going to open this up on this other screen. And all right, let me maximize that. All right, so we have 8 unique input combinations. What I'm going to do is I'm going to set the end time. I don't want this to run on forever because I just want to simulate it for 80 nanoseconds. So I'm going to go to edit, set end time, 80 tab. I'm going to type N for nanoseconds. If you don't want to use the keyboard, then you can use the drop down menu to get to nanoseconds. I click on OK, right? And I've got a smaller time frame. Right, what we need to do is we need to bring in our signals as well. Now, we do that by saying insert node or bus. So I right-clicked, insert node or bus. I go to Node Finder. I want to say list, but it tells me no nodes. It's telling me that because I need to run analysis and synthesis first. I'm going to say cancel. Right, I'm going to cancel this. I'm going to minimize this. And so back over here, I need to run analysis and synthesis. So I'm going to then double click on analysis and synthesis, and we should see an error being generated. So it tells me my waveform has been modified. Do I want to save my changes? No, not at this time. Now, it won't destroy the work that we've done. I'm just not ready to save it yet. So typically you run analysis and synthesis before you go to your waveform, right? Because the waveform depends on the results. All right, in this case, running analysis and synthesis generated an error, right? Errors show up in red. So this says that the top level design entity tutorial is undefined. How do I fix that? Well, since I only have one schematic here in the file, I don't have any design files named tutorial. And if we go back to hierarchy tab, right, by default, it says this was our top level entity. What we need to do is we need to change our top level entity when the name of the file that we're wanting to build from doesn't match what we had originally defined. So I'm going to go back over here to files. And so now with this file highlighted, I'm going to right click and I'm going to say set as top level entity. So if we go back to the hierarchy view here, now you can see that min SOP is the top level entity. Right. It also is generating a warning here about the number of processors. I don't like seeing warnings, so I'm going to go to assignments, settings. And I hate, for some reason, all right, brought it up on the screen, but I was able to move it over. All right, yours may come up in general view. What you want to do is you want to go to compilation process settings. Right, under that, if we say use all available processors and click on OK, right, that should get rid of that warning the next time we run this. So now let's run analysis and synthesis again, because we can't simulate as long as we have errors. I'm going to click on that. No, I don't want to save my changes to waveform yet. So now it looks like it's going to run through the analysis and synthesis, right? Because whenever we simulate, it's always going to run the simulation against whatever design we set as our top level entity. All right, so good. No errors. Notice the warning went away. And so now, right, what we can do is we can right click, insert node or boss, node finder, list, and now it's showing the pins from our design. So I want them all. So I'm going to click on the double greater than sign to select them all and bring them in, say okay. And now everything's here. Right. So now if I say file, save, right. It tries to save it. The first time it tries to save this with the name of waveform. And if you've only got one simulation in your file, that's fine. But what happens is if you have multiple simulations, it will still work. The next time you want to create a waveform simulation, it's going to name it waveform 1 and then waveform 2 and waveform 3. But that's a lot of times that's not very descriptive. As we go farther into the semester, and when we start having different circuits in our files and running multiple simulations, we're going to want to give them a better name. So what I'm going to do is, instead of naming this waveform, I'm going to say that this is my min SOP underscore sim. Right, so my min SOP simulation is what I'm going to name this. So I'm going to click on save. Right. Now, if I were to run this simulation, actually what we need to do is we need to generate the inputs. So what I also want to do is I want to group these 3 inputs together. So I'm just going to highlight the 3 of these. I'm going to right click. I'm going to go to grouping. I'm going to say group. I'm just going to call it input. That's my input group. What's handy now is we want to match the truth table, right? We want to count all the way from 000 to 111 or 0 to 7 in decimal. So with this highlighted, we can go up here to the C icon, right? Hover over that, your count value. And so it's going to start in binary at 000, right? It's starting with 000 because we've selected the 3 signals. It knows there's 3 bits in there. It's going to increment by 1. And I'm going to go with the default of counting every 10 nanoseconds. And I'm going to say, okay. So since I knew I had 8 unique inputs, 10 nanoseconds, 8 times 10 is 80 nanoseconds. That will show me every possible input combination from my truth table If we made the simulation go longer than 80 nanoseconds, basically it would have just started the count over again at 0, right, and show us the same thing in the simulation, which is not an error, but I just want to just see just what we need to see here. All right. So typically when we use the waveform before, we just said run functional simulation. So if I go to either the simulation menu or click on run functional simulation, it's going to prompt me that I haven't saved my changes. So yes, I want to save my changes. And what we're going to see is it's going to generate an error. Right. And the reason it generates the error is it's looking for a waveform called waveform. You probably can't see that in that red text, but it's saying that waveform.vwf specified with this test bench vector input file option does not exist. I'm going to close that down. So what I should have done, right, whenever we change the name, is we're going to go to simulation, simulation settings. Right. And right here in this line, it says vlog-work waveform.vwf.bt. So we want to change the name waveform. So I just highlight that. I'm going to backspace. And remember, I called this min SOP _ sim. So I have to give this the same name as my file name. If I change this here in this command, this will almost work. The other thing we need to do is up here in this long stream of settings, it's also referring to the path of our file. So on my computer, this is in the path of OneDrive desktop, this folder tutorial, and it's looking for a file called waveform.vwf, right? And same thing for the test bench file, it's going to look for that. If we scroll over that, and we don't have to go up here, we could change this by hand, change the name, but there's an easier way. After you make the name, change your file here, if you just click on restore defaults, what this does is this will then change these defaults up here. So notice it changed it to that name. So I'm going to go ahead and save that. All right, if I say run functional simulation now, it will prompt me to save this file again. So simulation, run functional simulation, right? I haven't, it's been modified. Do I want to save it? Yes. And what we should see now is it running the simulation for us. And it's popping up the output on the other screen. All right, so remember our ones in this occurred at, actually, let me pop that up, right? We expect to see ones at 0, 3, 4, and 5, zeros elsewhere. So if you look here, right, well, all of my inputs are 0, our output is a 1. Input of 3, so 0, 1, 1. My output is a 1, 4, 1, 0, 0 binary, 5, 1, 0, 1 binary. You can see for 3, 4, and 5, this is a 1. Everywhere else, 4, 1, 2, 6, and 7. You can see then that my output is a 0. Right? You could also change the radix of this. So by default, the radix was binary, but if you'd rather see unsigned decimal numbers here, you can see 0, 1, 2, 3, 4, 5, 6, and 7, right, which correspond then to our decimal terms we were using for the row numbers. Right. All right, so that shows that that circuit for that min SOP actually then produced the truth table results we expected. We've done that check. I'm just going to go ahead and close this output. I'm going to close the simulation here. Let's bring our Quartus project back up on the screen. And so now we want to create, all right, let's go ahead and create then our canonical sum of products. So let me pop this up. Right, so the canonical sum of products, this is where we solve. Canonical sum of products we solve for the ones, canonical product of sums we solve for the zeros. I want to then create this one, canonical product of sums. Okay. So what we're going to do is we're going to add another schematic. So we're going to go over here, we're going to say file, new, and block diagram schematic. Okay. Now, so I want to show you how to use the text tool. Right. So if you go up here, right, and hover over then this capital letter A, you'll see that's the text tool. Right. Once I click on that, anywhere I place the mouse within the design, I can start typing. So if I say f as a function of a comma b comma c parenthesis is equal to, now I don't think this is going to give me the Greek letter, but I'm going to say this is the product of 1, 2, 6, and 7. Right now that's rather small. When I'm done with this, now if I go click again, it's going to wait for me to type text somewhere else. I'm just going to go back over here and click on, right, the selection tool. And what you can do is you can make this text bigger. So if I go here and I actually, all right, I highlighted it. Sorry, I was double clicking. I click once, highlight it, right click, go to properties, and then you can change the font if you want. So, right, if I go ahead and say, well, let's make the font of that 18, right, that's much larger, easier to read. Right. What we need to do is I'm going to insert. Now, I could copy, and actually, let's go over here to the min SOP. I'm going to just highlight that, right? I'm going to say Control C for copy. I'm going to go back over here. I'm going to say Control V, or you can right click for paste, right? And while these are all highlighted, you can move them around as a unit, right? Here, I'm just going to go ahead and say, and let me use the magnifying glass so you can see this better. All right. Right, so I just copied the pins over and the NOT gates because I'm probably going to need most of these signals, A naught, B naught, C naught. Right. Otherwise, whenever you want to insert pins, right, you go to the insert the pin tool. Right, I'll show you how to use that for the output pin app. All right, so we've got our inputs. Whenever I do schematics, I try to reuse what I can from other schematics. And what we'll need for a product of sums is we are going to need 4 OR gates because we have 1, 2, 3, 4 products in the canonical product of sums. We need OR gates because those are our summation, our logical OR is our what we call the sums. And we need 4 of them, and they need to have 3 inputs because our function has 3 inputs. So if I right click and I say insert symbol and I say OR 3, so that gives me 3 input OR gate. I'm going to check repeat insert mode here. And I'm going to get 1, 2, 3, and 4. And I'm going to hit escape. All right. All right. Like I said, you could directly wire these together. But we know then the max term for max term 1 is going to be A ORed with B ORed with C naught. What I'm going to do here is I'm going to move the cursor here. I get the crosshair. I'm going to left click with my mouse. I'm going to pull this out, draw a wire. Well, this is highlighted. I'm just going to type A, capital letter A, right? So if I use the same name as what I've used for this pin here, that is equivalent to as if I had drawn a wire from here to here. I'm going to say Control Z to undo, right? And I'm naming the wires. So here, then I need to OR that with B. I'll just draw another wire while this is highlighted. I'm going to type B. And then I need to OR that with C naught. So while it's highlighted, I'm just going to type C naught. Right. And so I'm going to match by typing C naught, by matching this here. It's like literally directly wiring the two together. Now, if your wires are kind of running together and it becomes hard to read, I can just grab hold of this and drag it down a little bit. I can grab hold of this one, drag it up a little bit. And that makes that a little bit easier to read. So we can see the inputs to this gate will be A ORed with B ORed with C naught. Right? And then let's see. So for max term 2, right, that is going to be A ORed with B naught, ORed with C. Again, I can grab these individual wires, drag them away, make that a little bit easier to read. Okay, max term 6 is going to be A naught, ORed with B naught, ORed with C. Make that a little easier to read. Finally, max term 7 is A naught or B naught or C naught. A naught, B naught, C naught. And so as you're creating the wires, you can type the names right away. If later you discover that you've misnamed something or you've drawn a wire and want to name it later, you can always just highlight the wire, right click, bring up the properties menu. And what that does is it brings up a properties box where you could type in the name of your signal. Now I want this to be C naught. You can also do things like changing the font as well if you want. But I'm just going to click on OK. So that's another way that you can place a name on a wire and change that. All right, so here's our summation. We need to then, our product of these sums needs to be an AND gate. And so we need an AND gate. And how many inputs do you think we need to the AND gate? Well, we have 1, 2, 3, 4 terms. So we outputs from 4 OR gates need to flow into an AND gate. So I'm going to right click, insert symbol. Right, I'm going to type and 4. I only need 1. So let's place that here. And I'm going to add pins. I'm going to go to the pin tool. It's an output pin. Let me select that, hit escape, because I only wanted 1. I double click here, and that brought up the property. All right, so I'm going to name this CPOS for canonical product of sums. Connect that to this gate, and then here, right. Now you could name the wires coming out of here if you wanted to. In this case, I think this is just going to be easier enough, right? Nothing's going to cross over. This is just going to be easy enough to directly wire together without actually naming these. So we can have a mix in our design. Whatever you prefer, we just want to try to keep it fairly neat and readable. All right, so we've got this file. By default, remember, Quartus wants to name this with the name of block, right? In this case, block 1. What I want to do is I want to say file, save as, right? And I'm going to call this canonical underscore POS for product of sums. Click on save. All right. Now, let's say that I wanted to simulate this circuit, right? And maybe I don't want to simulate, I want to simulate this circuit to see if it's correct. In order to do that, I need to make this my top level design. If I were to click on analysis and synthesis, it would analyze both of these circuits to see if they're drawn correctly, if there's any syntax errors. Synthesis step is where it breaks things down into the appropriate gate levels. And of course, we've already drawn the gates, so we'd expect it to synthesize this design the same gates. But I need to make this one my top level. So I'm from hierarchy view, I'm going to go to files. I'm going to select canonical POS. I'm going to right click, set as top level entity. Again, if you go back here and look at hierarchy, you can see this is my top level entity. I'm going to then run analysis and synthesis. And hope that I don't get any errors. All right, no errors there. All right, let's go ahead and create a new simulation. I'm going to say file new. And right, So university program vector waveform under verification and debugging files. Again, edit, set end time to 80 nanoseconds. Insert node or bus, node finder, list, right? You can see now there are my inputs, there's CPOS because that's the top level design entity. Because that's top level design and it doesn't refer at all to that min POS circuit, right? There's no, that min POS pin doesn't appear here. All right, so I want all of these. I'm gonna say okay, okay. Again, I'm just going to grab all three of these. I'm gonna right click and put them in a group called input. Right. I'm going to say file, save. You can see it wants to come up and name this waveform, but I'm going to just call this Canon POS underscore sim. What I need to do then is I need to go to simulation settings, and write this line here where it says vlog-work waveform. I just need to give that the same name as the simulation Canon POS underscore sim. Restore defaults to change then the path up here. Save. File, save this, run functional simulation. Oh, I forgot to do the count value. Shame on me. I left all of these the default. It's 0 all the way across. Well, we know for our input 0, we should have an output of 1 in the circuit. That is correct. So shame on me. All right, I go to count value here, right? Start at 0, increment by 1, and say okay. All right. Control S is a quick keyboard way to save this. Run functional simulation. Right. All right. So what I was trying to do is here's my simulation output here. Right, we said that we expect zeros at 1, 2, 6, and 7. 1, 2, 6, and 7 are our zeros, ones everywhere else. This is correct. Again, I'm used to looking at the binary, but if you'd rather see this in decimal, you can select this input, right click, go to radix, and tell it you want unsigned decimal, and you say 0, 1, 2, 3, 4, 5, 6, 7. All right, so let me close that. All right, now we need the canonical sum of products. And I have already drawn that one. Let me just drag that into this folder. So I'm going to copy this. I'm going to put this in our folder, paste it in here. All right, let's pop up Quartus, close that waveform. And, oh, sorry. All right, so over here in Quartus, I'm going to say File, Open, and here's my Canon SOP. I'm going to open that up and let's zoom this out a little bit. All right, so this one I already drew so that we don't have to go through drawing it again. Again, I use the text tool to remind me that we have 4 terms that should reduce a 1, right? We've got our inputs A, B, and C. We've got our signals A naught, B naught, C naught labeled here. Sum of products, our product terms are these AND gates. These AND gates have 3 inputs, right? Because we have 3 input variables. So for min term 0, this is A naught and with B naught and with C naught. Right, for min term 3, it's A naught and with B and with C. Min term 4, A and with B naught and with C naught. Min term 5, A and with B naught and with C. And if you find it helpful in some of your early designs, you could also use the text tool. If I make this active, if I wanted to put a little note here and say, oh, this is min term 5. Oops, I hit escape and deleted that. Sorry, if I want to put it. So this is not the same as naming a wire. If I just put this little note here, let me turn this off, min term 5. One of the reasons this shows in green, when we use the text tool, these are just a set of comments that help a human reader. They aren't actually part of our final design. So I didn't actually name this wire min term 5, right? And so with this being shown in green, this should let you know that this is a comment drawn by the text tool. If I want to name the wire, I actually have to click on the name of the wire. If I go to properties, you can see this wire has no name. All right, so if you find it convenient to name some of this as you're working along, especially if you get errors later and you want to go back and check, it's a really quick way, right, to look at something and know what it is you're trying to represent there. Especially as you're new to min terms and max terms, this might not be as readily obvious to you right away that A and with B not and with C is actually min term 5. All right, so we have then here are our product terms, our low-level AND gates. Remember, sum of products is an AND OR configuration. So these outputs flow into the OR. The logical ORing is our summation. And then I named the output of this CSOP. All right. Now we want to add this to our project environment. And since this is currently active, I can just go to project, add current file to project. I'm going to click on the save icon to save that little change that I made there. And so now in our environment, we have these 3 schematics. Right? I could simulate this, but what we'll do now is let's go ahead and start creating some block symbols. So with this file currently active, Canon SOP, I'm going to go to File, Create Update, and Create Symbol Files for Current File. Click on that. What it does is it opens a window, and it's going to give this an extension of BSF for block symbol file, and it's going to use the same name as the schematic. I have no reason to change the name. I want to keep that the same. So I'm going to, and remember, it's going to put it in my project folder out in the main folder. So I'll just click on save, and it says it created the block symbol file. All right. So let's go ahead and create another file, another schematic. So file new, let's create a block diagram schematic file. And now, let's see. I still want my inputs of A, B, and C into this circuit. And so I'm kind of lazy. I'm going to highlight those input pins, Control C to copy, Control V over here. Let me magnify that. All right. So what we're going to do is we're going to insert this symbol. If you right click and say insert symbol, all right. By default, since I've been working with the gate primitives, that comes up. But what I want to do is when we create block symbol files, those become part of our project. So if we click on the project folder here, click on Canon SOP, that's the symbol that was created for our canonical sum of products. I'm going to say OK. I'm going to place that here. And what that does is it creates a symbolic representation of our circuit. Right? When you want to reuse a circuit again, if we wanted to reuse this in another design, right, another schematic, we wouldn't want to have to draw this again, right? We've already drawn it. We haven't tested it. The others have been tested. They've been tested. We know they work. We wouldn't want to draw this, right? So that's why we create the symbol. And then over here, when we insert the symbol, right, that symbol is just sort of a black box abstract encapsulation of the circuit, but it gives us, then think of it as though we copied the circuit into this design. Right. Like I said, if we start copying a lot of other circuits in there, it makes the design hard to read. This makes it very easy to read. We know that this particular block represents our canonical sum of products circuit. And then we can do the same thing for our other file. So let's go to canonical POS. All right, that's my active file. I'm going to go File, Create Update, Create Symbol Files for current file. Save that. OK. While I'm at it, I'm going to go to min SOP. I'm going to say File, Create Update, Create Symbol File for current file. Name there. Told me it created the file. OK. Right now, if we hadn't already compiled these, if there was some sort of compilation error, right, it likely would have come up with that and not been able to create the symbol file. So back over here in this new schematic, again, if I right click and I say insert symbol, right, now you can see, right, I've got my canonical POS symbol. Again, insert symbol. Let's grab our min SOP symbol here. Right. And so it's like we've copied, right, each one of these circuits in here. We have that functionality. Like I said, it's just encapsulated in this block symbol. Right. And so we're going to end up using this as the top level, right? Your lab, what we want to do is we want to show that all three of these circuits produce the same output. And so if I wanted to, I could go ahead and name wires here, or we could just do that. Ugly connection there. Right. I could just start doing this to connect everything to A. Right. We connect A to A. I'm going to connect B to B. And I'm going to connect C to C here. All right. All right. And now I need some output pins. Again, if I go to pin tool, select output. I have 3 outputs. Just go ahead and I'm going to right click and say detach and blow this up so we can see the whole thing. And I'm just going to connect this output here, this output here, this one here. And all right. So I'm going to have CSOP for Canonical Sum of Products, CPOS, and M. I'm going to call this MSOP for min SOP. All right. And it's okay with these pin names here that I use the same names that we use in these blocks. These names are internal to this module. Right? These names belong to this particular module schematic. Right? These names we can use again because they're in a different schematic. All right. Same way with A, B, and C. I can use these names again because I'm only using them once in the schematic. Anything that's inside this block is internal to the circuit. Right. So even though we use the same names, there won't be a naming conflict. Like I could have called this X, Y, and Z, but I still could have connected X to all the A's and so forth. All right. All right. If I want to touch that again, I can do that. What we want to do is we want to save this now. I'm going to say File, Save. And now if we want to use that name tutorial as our top level design, we could do that. We could give this some other name. I'm just going to go ahead and use that name tutorial for this circuit. Right. I'm going to right click on this and make this my top level entity. And now I'm going to run analysis and synthesis. And so as this runs analysis and synthesis, it's running it on all of the files in our project. You can see as it scrolls by, it's saying it found these different design units, right? Min SOP BDF, Canonical, POS BDF, and so on. And so it actually goes through and analyzes all of these and synthesizes all of them, right? But because this is our top level, these will be the pins, A, B, and C, and the input pins and the output pins that are being used in our simulation. Right. Again, let's create a new simulation. And here, File, New, University Program. Again, edit, set end time, 80 nanoseconds. Insert node or bus, node finder, list, grab them all. Okay, okay. I'm going to grab these 3, create the input group. All right, Control S to save. All right, waveform. I'll call it tutorial underscore sim. All right. Simulation settings, since I didn't name it waveform, right? I've got to change that name here to tutorial underscore sim, hit restore defaults to correct those paths, click on save. Control S to save this, run functional simulation. Oh, I forgot to do the count value. Once I make that mistake, it seems like I keep making it. All right, Control S, run functional simulation. All right, so now, right, this is the output CPOS of our canonical product of sum circuit. The output of our canonical sum of product circuit is CSOP. MSOP is the output of our min SOP. And we would expect all of these are supposed to be logically equivalent expressions for our circuit. They're all based on that unique truth table. And we said our ones should occur at 0, 3, 4, and 5, which they are for all three circuits. And our zeros are occurring at 1, 2, 6, and 7. So then this shows that all of these circuits are logically equivalent. And that is what you will be doing in your lab assignment, implementing 3 different circuits, running a simulation to show that they're logically equivalent. Right? You'll be using these block symbols and in a top level schematic. So then hopefully then this tutorial should get you through what you need to do for the lab. Oh, here's something else I should cover. Let's say that we had a mistake. Let's say that one of our circuits was wrong. All right. So let's say, all right, maybe it doesn't matter. Let's say maybe one of these was wrong. And let's say that I had to go ahead and make a change here. Maybe I accidentally had typed this something as, ooh, didn't want that to happen. Right. Maybe I had typed C instead of C naught. If you have to go in and fix something in the circuit and make a change, so I'm just going to go ahead and name that C naught again, but actually, let me make the mistake. Let me name it C. This should be C naught. So let me name this C, Control S to save it. Right. Whenever you make a change then to a schematic where you then use the block. So over here in this file, we've used this block. And so here, right, this particular block, if I highlight this and right click, I can go to update symbol or block. And it's going to pop open a menu and just let me update the selected symbol. Or if I've used this multiple places in multiple files, I can check on all occurrences of selected symbols or blocks to change across multiple files, or if I just want to change it in this file, I can do that. But I'll just click on OK. And then this will update this symbol for the changes I made in the circuit. Now, I will have to run analysis and synthesis again. So yeah, that's been modified. I want to save it. And what we should see, we're going to run the simulation again to show that we should have an error in our output. That's not a compilation error in our wiring. All right, so analysis synthesis run. I'm going to open tutorial sim.bwf. I can just rerun this simulation again because I don't need to make any changes to the simulation. Right, I have the same top level. And you can see, right, the change I made into canonical POS where I made that a C. Notice now we've got a 1 output for our binary input of 111 or decimal 7. Right, these two are correct. So we look at this and we say, oh, well, we know that the fault lies in the canonical product of sums circuit. That's what's generating this output. And it has to do with whatever term is generating then, right, max term 7. Close that. I could leave that open. So we would go then here to our canonical POS, right? That's where I made the error. We say, oh, that's supposed to be C naught. let's correct that. So C not, click on OK, Control S to save. Let's go back over here to this. Right, I'm going to right click on it. I'm going to say update symbol or block. I'll say all symbols or blocks in this file. Control S to save. And now we have to run analysis and synthesis again. Anytime you make a change to your design, you need to run analysis and synthesis. Right, which as you can see, this tutorial is taking a while. We could get to some errors. And now it seems like I have introduced an error in this circuit. Legal name CPOS, pin name already exists, overlaps another pin in a block or symbol. How I did that, I've got some wires coming in here, which can make short circuits. Didn't notice that before. Oh, the joys of Quartus. Save this. All right. So usually when we get an error, if we double click, that usually takes us to the file where it's telling us where the error is. But it's really not taking me. Sometimes it'll take you to the actual block or pin. When I click on that, I'm not seeing it take me there. What I'm going to do is, if the error is in this file, and it likely is because when I tried to elaborate this is elaborating entity tutorial, it's where it came up with the error. What I'm going to do is I am going to right click and say remove file from project. Actually, I was going to make a video about doing this, so I guess it's a good thing I have the error. Look at the bright side. Yeah, I want to remove this file from the project. So if you have files in your project that are generating errors and you don't know how to quite fix the error yet, or you want to check something else, you can remove that file from your project. So if I go back over here to Canonical POS again, I'm going to right click and set this is the top level entity. I'm going to run analysis and synthesis on this file. I'm going to say, is the fault within this particular file? No, the fault was not within that file. And if I just want to double check to see if I corrected this, right, we have this simulation, Canonical POS sim. So I should just be able to open this up since I just made that the top level entity, and that's what we ran. We ran this. This is now our top level entity. I should just be able to run this simulation. I'm going to click on run functional simulation, see if it runs for us. I say I should, once in a while Quartus throws up an error. All right, so CPOS, that looks good, right? We got rid of that error. And so that circuit appears to be okay. Oh, maybe I need to go file, create, update, create symbol files for current file. If I do this again, right, and just overwrite what was there. Yes, I want to replace it. Yeah, it created the symbol file. Let's go ahead and then file open. Let's bring back this tutorial PDF here. Can't see anything that looks really wrong there. I'm going to say project, add current file to project. I'm going to right click and set that as top level entity. We'll run analysis and synthesis. So these are some of the things you'll be getting used to with the Quartus software. A legal name CPOS, pin name already exists. Overlaps another pin blocker symbol. Sometimes this literally has to do with the way I drew something. Did I have two of them there? Actually, clicked, it looks like there was a second one there. Delete, let's put a new one here. Let's call this, I should be able to call this CPOS. Like I said, worked before and then I messed it up, but it almost looked like there was another one there. When it said something overlaps, that usually means you have two of something. If that was the case, one was lying on top of the other. I don't really quite understand why we didn't have it the first time, unless a series of keystrokes made me mess this up. And create another. So Control S to save, run analysis and synthesis, cross our fingers that I won't end up getting mad at this. The software can be frustrating to deal with. Ooh, that looks good. All right, so let's reopen Tutorial Sim. Let's say run functional simulation. So yeah, when it says a pin overlaps, usually something is literally laying on top of another one. All right, so notice this is correct now. This then, I corrected the error that I introduced and the extra error I introduced. This then is what we want. So that gave you some good examples of how to troubleshoot when Quartus picks up errors, how to remove schematics that are giving you errors from the projects, how to create symbols, right? How to update those symbols. All right, so you should be all ready to complete your lab assignment. Good luck, everybody. Have fun with Quartus. I will see you in class and or the next video.